These are the world's smallest machines. Each would perch comfortably on the edge of a human hair. They work unseen, enabling our devices to sense, move, and interact with the world, guiding medical procedures, even bringing movies to the screen. It all began with Kurt Petersen and a gigantic innovation you couldn't see without a microscope. It was an era of grand ambition set to the roar of rockets and the scraping of slide rules. The space race fueled the American dream, and it was a big dream. Growing up in Northern California, Kurt Petersen was swept up in it.
I was designing like human, rockets that could take people to the moon and Mars and stuff. I was thinking bigger, yeah.
But things change. The space race would wind down. And in the 1970s, with a PhD in electrical engineering from MIT, Petersen suddenly started thinking small. He can remember the day it happened. He'd taken a position as an IBM researcher.
I'm a friendly guy, so I would wander the halls just to find out what people were doing. And I wandered down this one hallway, and there's this huge ink stain on the floor. And so I went in there, and what are you guys up to?
In the lab, Petersen found a team building some of the first inkjet nozzles. These were mechanical devices on tiny chips. He wondered, if you could carve something so precise as little channels and valves on such a small chip, could you build entire machines at this scale? Petersen got to work etching, making complex machines with moving parts too small to see with the naked eye.
So my first devices were light modulators. But then I discovered, I could make these into switches. So tiny, tiny switches. Again, you have to see them in a microscope. And people were amazed that you could build such mechanical structures that small.
Petersen wrote a seminal publication touting this novel microscopic machinery, rallying enthusiasts around the country. A new field of research was born, MEMS, micro-electromechanical systems. Petersen recognized the power of MEMS, how it combined the electricity conducting abilities of silicon with microscopic moving parts, allowing future devices to sense, move, and interact with the world. The tiny size would make them lightweight, energy efficient, and easily integrated into almost any engineering scenario.
He pushed the boundaries of the technology early on, innovating through a series of startups. Novasensor introduced tiny pressure sensors used in catheters during heart surgery.
A few years after I founded Novasensor, my father had open heart surgery. My pressure sensors were sensing his blood pressure during his operation. How great is that?
After the turn of the millennium, Petersen helped bring the anthrax scare to an end with an anthrax-detecting chip that to this day still scans all U.S. mail. Years later, Petersen's company Cepheid harnessed MEMS-based microfluidics to develop rapid DNA detection systems, and even providing the first rapid COVID PCR tests during the pandemic. Today, MEMS devices are everywhere. They're the microscopic accelerometers and gyroscopes inside our phones, the tiny mirrors inside digital projectors beaming movies onto screens. And the next big leap might be the embodiment, literally, of AI.
Well, there's a theory that consciousness comes from experiencing the world, feeling the world, seeing the world, smelling the world, hearing the world, interacting with the world. The only way a computer can interact with the world is through sensors. The next step in AI is having AI hooked up to a robot which is interacting with and sensing the world. And I think that's going to happen. And MEMS is going to allow that to happen.
Petersen's work helps us reimagine the role of technology itself, from tools largely reliant on human input to semi-autonomous assistive devices that sense the environment in ways we can't, bridging the physical world around us with ever-expanding digital domains.